All right. So let's jump right into it. So let's ask the question: what is software development? Software development refers to a set of computer science activities dedicated to the process of creating, designing, deploying, and supporting software. So anything that has to do with creating a software, um, designing it, developing it, supporting it, creating it, even managing it is among. So as a product manager, if you're managing a software, you're involved in the creating of the software um, for any purpose that it is being used for. So that is basically what software development is. Now, what is software? Software is a set of instructions or programs that tell the computer what to do. So it is independent of hardware and makes computers programmable. So in the name of time, guys, so for your computer to for a computer or for your phone to be able to send message to another computer or another phone somewhere, or to just interact with even within itself, what makes that impossible? It is the software. So software are those things that we cannot see with our eyes, are those inbuilt stuff, those things that make the computer intelligent. So that is exactly what software is. So and then there are three basic types of software. We have the system software, we have the programming software, and we have the application software. So what's the system software? The system software is to provide core function such as operating system, disk management, utilities, hardware management, and other operational software, other operational necessities. So, this system software is the main software, is the main thing, that thing inside your device that even makes it possible for it to even be a usable device. So it is the heartbeat of your system or whatever, computer or laptop. So that is what, without the system software, I'm not sure it can be able to run in any capacity. I have then the programming software. So it is to give programmers tools such as text editors, compilers, linkers, debuggers, and other tools to create code. So um, these are just tools people that programmers use, and these are just software which are tools in itself to help them create more softwares. So they're not like you will not use it in your computer, but software engineers, people that create the software that will be in your computer, use this type of software to be able to create the code. So that's what programming software is all about. The application software, as the name imply, applications or apps, as you call it, is to help users perform tasks. So Google Meets that are using to have this class, our Slack channel, WhatsApp, YouTube, etc. These are all applications, softwares. So they help the users to be able to perform certain tasks. They help us to be able to use our computer or our phone very well. So application software just are independent of your system, but it is necessary it is important for us tasks that our system software cannot um, do. No, I know. I think that should be is the one that is called embedded software. So embedded software is not really popular, but it is used to control machine and devices, and that is not considered computers. That is not necessarily considered computers. So you have your this thing self-driving cars and robots etc. So this is where we use embedded software in. So it is a type of software, but it's not really classified under these three main groups of software, but it's part of the software that is normally used these days, especially in regards to Internet of Things, IoT. So it makes it's just used for smart living and all of that stop talking about. So software development is primarily conducted by programmers, software engineers, and software developers. And these are distinct roles, but they interact and overlap, and then they're just cross-functional. So we have programmers or coders, we have software engineers, and then we have software developers. But we're not going to that because that's not why we are here. So um, so yeah, so it might be yeah, people might be we might normally call people someone that is a software engineer, call them a software developer now or a programmer, a coder. Yeah, yes, we can refer to them as that, although they're distinct, but although they are the same, they are similar, but they are distinct. But we're not going to start. So, what are the steps in the software development process? So, software development involves so many steps. Just go through it. We have selecting a methodology. So, we'll go into this particular first point I've made now. So, we'll look into it further after this introduction. We'll go into the types of methodology that there are. But let's look at other options. We have selecting a methodology. We have gathering requirements, and this is understand document and what is required by users and by stakeholder. So when you're creating a PRD, this is gathering requirements. Choosing or building an architecture. We have developing a design, building a model, constructing a code, testing, and then managing configuration and defects, and then the constant iteration. So these are all steps when developing a software, right? So um, what are the top four types of software development methodologies I'm looking at today? We have the agile development methodology. So two, we have the DevOps development methodology. Three, we have the waterfall development methodology. And four, we have the rapid application development methodology. So I said the first one and this is the most widely used methodology is the agile development methodology. So it's in fact, you want to get a job now in a tech firm or somewhere, you're most likely to use Agile. Agile is now what many companies use these days. But even as a general company is using Agile, some teams might be using DevOps or any other type of development methodology. So it can be intertwined at the same time. But Agile is most preferred by companies and it's distinct from this one. So let's just look at Agile. Teams use the Agile development methodology to minimize risks, such as bugs, changing requirements, etc. So, as you all know, Agile is continually changing. Agile is not static. Agile means constant iteration, and it means doing things bit by bit. You don't just do everything at this stretch and then close whatever you're building. Agile proposes constant collaboration with your team and your customers, and you always have to adapt. For any time you're building and things change, you always have to change the scope and change your priorities, and so that you can build what's beneficial at the end and not just what you set out to do. So it encourages constant changing of priorities and the iterations once the decision has been built. So there are different type forms of this agile development methodology. We have Scrum, we have Crystal, Extreme Programming, and then we have feature driven development. So these are all under your agile. So like I said, so agile has to do with having a backlog of tasks, then you collaborate, and once you collaborate with your team, your customer, and this is where project managers come in. This is where they play a very important role because you mostly be managing the backlog, the product backlog. So once you have the backlog of tasks, you bring them, you bring which one to do it in each sprint or a given period of time, and then you constantly iterate and then have your daily review. And then after the daily review, it's okay. And then if it's fine, if it's good, then you send the deliverables. So after you do, and then agile, it preaches constant deliverables. So if you finish building and then at the end of each sprint, you must deliver a working software. So even if you're not able to complete it at that sprint, you can take it to the next. So it does that it helps us build things bit by bit. So you build the landing page of your this thing. You want to build the landing page of your website or product or whatever. You use that series to build it, you deliver it. You want to build the login this thing or login feature, you build it in a sprint to keep it. You want to build the cart system of your products, you build it to keep it. You want to build the payment system of your products, you build this feature one by one, and then iterate and then bring them to at the end of the entire product development process, even does not end, then bring it together and it becomes a fully functional, built functional, working product. But then again, we have to collaborate and continue to iterate and deliver. So, what are the pros of this development methodology? So it allows software to be released in iterations, and iterative releases improve efficiency by allowing teams to find and fix defects and align expectations early on. So they allow users to realize software benefits earlier with frequent incremental improvements. So what does that mean? It just makes sure that for everything you build, it's easier for you to always improve on that stuff. So always find defects because you've not integrated this with other features you built. So since it's standalone, your QA might just be QA who is not normally heavily involved in the day-to-day building of the software, can go back and be looking at it. Okay, there's a bug here, it has to be fixed. Like this is here, it has to be fixed. So it helps you and your team to develop find issues before it just bought light before it is shipped, the project is shipped as a whole. So that's what agile helps us achieve. That's one of the pros. So one of the cons says agile development relies on real time communication. So new users also like the documentation they need to get speed. Um, they require a huge time commitment from users and are labor intensive, and because developers must fully complete each feature within each iteration for user approval. Again, this what does this say? This in this kind of process, it involves constant collaboration with your customers. In the normal sector, your customer has to be like your day-to-day activity, whatever you're building, who you're building for, or the owner of the work, whoever you're building for, whatever, or your stakeholders, they have to be in the know at each and point. So, and they're not your team, so things can get lost somewhere. So when you need to have to go and tell them, okay, this is what happened, this other, it might just cause friction, but teams have found ways to be able to deal with that. So it shouldn't be much of a problem, although it's quite a problem. So let us look at DevOps development methodology. So DevOps is not just a development methodology, but also a set of practices that support an organizational culture. So DevOps, DevOps deployment centers on organizational change that enhances collaboration between the departments responsible for different segments of the development lifecycle, such as development, QA, and operations. So what of DevOps means? It means different teams, wholly different teams, different departments, different sections, different ways coming together to build a particular product or feature. So it's even if it's not everybody in each team, so two or two or three or multiple people from each team can come together um build a solution or to build a software or to just like to do something or to fix something. So and then DevOps is just it's kind of it depends on the organization. It's kind of like how organization wants to improve collaboration or how they want to improve team building or how the culture of the organization. So DevOps involves different teams coming together to build, and also it involves and um it's in a kind of a loop. There's this loop that DevOps is like that DevOps is bounded on. So you have to plan first. You plan, you code. Once you code the software, you build that stuff you're building. Then you test. Then release. After you release, you develop again. So now, code, build, uh, um, test, and release. Then that one is number one. That's the first thing you do, which is part of the development process. Then deployment. Then you deploy, you operate, you monitor. So this one this and the last part you deploy, you operate, and you monitor. So this is how DevOps. So they're not standalone. So it's on a loop. So it's kind of go round and round and round and round and round. It's not something that is just on a standalone. It just makes sense to be constantly in motion, to cover moving, so that there is no break in transmission or something. So things are being done on a rolling basis. So what are the pros? DevOps is focused on improving time to market, lowering the failure rate of new releases, shortening the lead time between fixes, and minimizing disruption while maximizing reliability. So to achieve this, DevOps organization aims to automate continuous deployment. So to ensure everything happens smoothly and reliably. So with DevOps, things have to be automated and have to be continually be done. So it is always happening at a constant. It is on a rolling basis. Things does not stop. So also ask about the cons. So some customers does not want continuous updates to their systems. They really don't want you to keep on doing some things to the system that maybe you guys have already talked about and they've agreed to it. So they want you to build and keep, and then except you find the bug and then let them know. So some industries have regulations that require extensive testing before a project can move to the operation phase. If different departments use different environments, undetected issues can slip into production. And this is the most important part of all this thing. With all this with this software development methodology, if different teams are working on a particular um, um, a feature, and then that like I know when I was explaining, I told you that even in agile, even in agile, being in an organization, other teams can use different methodologies they like. So when different teams come together in a huge big tech like Apple or Microsoft, things are not being done in the same way. Things, there are multiple hundreds of teams that are being doing this in this kind of big companies. Our director would have thousands of workers. So a team can be comprising of 10 to 15 people. That is the team. They have a team lead. They have all the software engineers. They have all the designers, and they have the product managers that will handle them in that team. What could they be working on? Maybe for something like Apple, their problem might be on how to improve the camera feature in iPhones. Another thing is somewhere. What is the issue? How to improve the operating system software of the iPhone. Another thing is also what is the issue? How to improve FaceTime feature on the iPhone. So different things and all these kind of different they are starting to do. What are they coming on to build an iPhone? So and this thing they might have ways they operate around of that stuff. So when you go deep into Scrum, I think that the house we had the Scrum of Scrum and different 40 name. So this is so you will learn how different things can come together to build a product seamlessly. Frictions abound, but at the end of the day, it works. So this is a problem here. So when if a department is using a different feature and a different environment or different process, and other things are not aware or are not up to date on how that it was, problem can arise in that situation. So let's move on to the third one. You have the waterfall development methodology. So this is really the first type, like the earliest type of software development methodology before Agile came and became the one that people use regularly these days. So it says that many consider the waterfall method to be the most traditional software development methodology. So the waterfall method is a rigid linear model that consists of sequential phases, requirements, design, implementation, verification, maintenance, focusing on distinct goals. Each phase must be 100% complete before the next phase can start. There's usually no process of going back to modify the project or direction. So yeah, one of the waterfall is rigid, it's just straight, it's just a straight line. For you to build for you to use such a waterfall methodology, it means that there is no room for iteration. It means that things has to be 100%, like you have to get it right at that first time. Like before you start building, there is no room for error. One, you have to make sure that things are perfectly planned and 100% sure of this process you're using or this or this code that you've written. So it has to be clean. There's no room for bugs, fixes, or anything. The moment anything happens to the software, it has crashed. It's no longer useful. So that's why many organizations have done away with waterfall. Although waterfall can still be in can still be how will I be modernized or maneuvered to include the agile processes. So waterfall again, you just build at once. No time for iteration or anything. But even collaboration self, there's there's no much collaboration, especially with the customers or users. So you just have to follow the sequential process of building software, and which is like you guys said, you have to get the requirements, you have to design, implement, verify, and maintain. So it's just straight. Most time, maintaining just comes in there because of agile. Most time, once you build it, you just hope it doesn't crash, which is why you maintain it. But it's just utility fixes can do to maintain it. And if it's too bad, it just cannot work again. So, what are the pros? So, the linear nature of the waterfall development method makes it easy to understand and manage projects. Projects with clear objective and stable requirements can best use the waterfall method. So, if you're clear of what you want to build, you're sure that nothing can come again and change it. No requirements can change it. So we want to use waterfall, but as uh, as many have found that it's not always the case most times. So, but that's one of the pros of software of waterfall. And one of the cons is that the waterfall development method is often slow and costly due to its rigid structure and tight controls. So it has to be it can be very slow because of you're not coming back to build whatever you've already built. So you have to make sure you do it slowly to make sure that you're getting it right at that point. And this can be really costly both for the team and the organization. So again, waterfall is the traditional method. It's what has been used for a while until 2001 when the Agile Manifesto was um, when Agile Manifesto was developed, and then people now had to do away with Agile. Agile was sorry, had to do away with had to do away with um waterfall and then move to Agile. So yeah, so waterfall is very old and that's that. So we have the rapid application developments (RAD). This is a condensed development process that produces a high quality system with low investment costs. The RAD process allows developers to quickly adjust to shifting requirements in a fast-paced and constantly changing market. The ability to quickly adjust is what allows such a low investment cost. So this rapid application development method contains four phases: requirements planning, user design, construction, and cutover. So again, in Agile, we have the lean Agile development style. So this is when you build something with um, um, something very quickly, and this is when you don't want to waste a lot of money or resources on something. So you have to be as narrow as you can and as quick as you can, and you have to be focused on this. You don't, as much as you can, don't try to go out of scope of what you're building. Because once left of scope, errors can just scatter. So you have to make sure, even if you've already gathered requirements, you have to streamline it to make sure that it fits into what they must have for your users. So that's how rapid works. So it's it's very small. It's very small. It's very narrow. So it helps you to change requirements if needs be, if need be at all. So and it's very quick. So you don't have to start going back and then discussing with your team or the overall team or your customers um on how to best to do it. So you just look at it and know that okay, this is becoming too broad. Let us streamline it and make sure that we are following is a very lean path towards our goal. So that's what rapid application development rapid application development methodology seeks to achieve in this case. Again, it has four different stages. You have requirements planning. You have to plan what should be needed for your project or your feature. User design. You talk to your users and then you design sorry how um how the requirements can fit into what they want, exactly what they want, what that their need. So you make sure that everything you're doing will be centered around your users' need. Then you construction phase. Then well, after the construction phase, they have the cutover where you remove unnecessary stuff. So user design and construction. So these um, are often like again the user design and construction. These are often in a loop. They go round and round. They're always done again until the user says that this is what they want. So you don't want to waste your time on something, or you don't want to waste resources on a particular feature or features. So you have to constantly do your user design and construct until the user says, okay, this is what I want. And then all the other necessary stuff that might have crept in along the way can be cut out. And then you ship your products. So, what are the pros? So, rapid application development is most effective for projects with a well-defined business objective and clearly defined user groups. So, and which are not complex. So, again, for this for you to use this development, this is not a very popular development. It's one of the outliers. It's not a very popular development method. So for you to use this rapid, you have to have a select group of users. Like what to build, you have to meet the direct need of a particular set of users. So you don't have to worry yourself about what else they can use this for, or who else might be able to use this particular feature or product. It is for a well-defined group of people that you're building for, and then a clear business objective to what do your company intend to achieve with this feature or product. Once that objective has been defined, or your group of users have been defined, then you go into your um rapid application development. So you use this methodology. So it helps you build exactly those things that are in mind of both your business, your stakeholder, which is the business, and then the select group of users. So that's one of the pros of um, rapid application development. It does not need you to go beyond the scope or go too deep or go too far, go too wide. It's just lean and straightforward. So what are the cons? So this rapid, right? It requires stable team composition with highly skilled developers, and then your users who are deeply knowledgeable about the application area. So this is one of the cons. So for you to use this development methodology, there is no room for a junior or an upcoming developer to work on this kind of methodology, because you have to be very skilled, because you're building something that has to meet a goal that has to be direct at what it's solving. So you 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 cannot use juniors or people that are still learning for this kind of system. Rather, it will have to be required for senior developers or senior project managers to be able to guide the team on want to build. And then the users that you're building for, or the users or users you use for, have to be well knowledgeable in that area of stuff, or that area or the project you're trying to build or whatever. You have to be knowledgeable of it, so that they help you build exactly what your select group of users want. So it can be really tricky. It can be really tricky, and a lot of things can really be lost somewhere or not done properly. So again, we had four different software development methodology. We had the agile development methodology, we have the DevOps, we have the waterfall, and we have the rapid application development methodology. Again, these are just ways why you can build a software. Whose camera is whose videos? Whose sorry. Please mute your camera. Mute your mic, sorry. If I'm on your hand is raised, what do you want to say?
Yes. Good evening.
Good evening.
Oh, I was actually thinking that you could share your screen. Share what you're actually teaching us today. I don't know.
Oh, maybe you joined later. I complained that my laptop is off. So,
Oh, okay.
yes. So, apologies again. Again, for those that joined this late, um, that just bought it, but I don't have that. My laptop has been off because I was working with it all day, and it just went off, and I didn't have power. So that's why I'm not sharing my screen today. But once after this class, and once I get my laptop up and running, I will surely share the slide with you guys. Again, apologies, is just beyond my control, but the class had to go on, and at least I was available for this class. So we just go with it. Again, apologies for that. Hopefully tomorrow that won't be the case. So now, let us go to software development life cycle, and so, or SDLC as it's popularly called. So, software development cycle is a set of steps used to create a software application. It's used to create software applications So these steps divide the development process into tasks that can be assigned, completed, and measured. So I'm sure you guys must have heard of software development life cycle. Like it's literally one of those things that you'll be hearing every time. Like for you to build a software product, it has to go through some steps. And basically, as a tech, someone in tech is if someone asking you, what do you use in building your this thing, what do you use your brain? Sorry to be saying say we saying too much. You can just say I use the software development life cycle. That's how I use and build my project or my feature, whatever. So software development life cycle is the application of standard business practices to building software applications. It is typically divided into 6 to 8 steps, which include planning, requirements, design, build, document, test, deploy, maintain. So again, many of these are saying that one. We talked about all this, some of these steps when we're talking about types of development methodology. So, but then again, the software development life cycle, they have to follow these steps. So again, they are divided into typically 6 to 8. You have planning. You have to plan with your team. You have to discuss with your stakeholder and all of that. Gather requirements. You gather requirements from users, from any the different ways to gather requirements, user behaviors, from the stakeholders, from the team, everything you gather requirements and documents. This is one of the um, one of the top priorities, top duties of a product manager. Gathering requirements. Don't forget that. Then you design. So you help your team to design what is going to be built and make sure that you have a mental picture or a visual picture of what you're trying to build. And then you build as a building, you document everything you've built, every code you've written, you document it. Then you test. Sometimes document is not there. So well, it's part of it. So you test what you built. After testing and making sure that it's up to standards, you deploy. Once you deploy your product or what to do the project or whatever, then you maintain it. You make sure that it is in constant usage, it is in a good shape all year round, all month round, all week round. So these are the steps involved in the software development life cycle. So some project managers change it to product manager. You combine, split, or omit steps depending on the project scope. These are the core components recommended for all software development projects. So again, as a project manager, you might look at what you're trying to build in the future and be like, so how do we do this? Are all these steps necessary, or should they be done like that? But especially when it's a small feature you're building, so I'm not a really huge feature. So instead of trying to waste the team's time, especially when you have your daily stand up and discuss about this stuff, I have your sprints planning and all of that. So you can decide to just combine some stuff. So planning and gathering requirements can come at once, and then design and build can be done at once. So it's always so you can always bend some of these things to fit your ideal situation at a point in time. And but the goal is make sure that is to deliver a software or a product at the end of your sprint or the development process. So SDLC is a way to measure and improve the development process. It allows a fine-grained analysis of each step of the process. This in turn help companies maximize efficiency at each stage. So SDLC just helps us to mention that um, that we are not doing things haphazardly. That you are following a laid down good step of how to build software. So even if you're using agile water, again, some of this development methodology betray the development life cycle. So everything will not be 100% ideal. So even as a product manager, when you get to your company, you see that so things that you'll be like this editor of a product manager, you find yourself struggling with it because it's different from what you know you should be doing. You know you're supposed to be doing this thing, but they're not doing how it should be done. But then again, it's not your duty to fight it. You know that things are different for different organizations, to be honest. So the goal is just to meet the demands of your customers and the business objectives too. So yeah, that's what you should keep in mind. So a lot of things might not be 100% how you envisaged it or how it should be, or blah 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 blah. And yet you might be wanting to say, but this is how you should go. This is how you should go. Yeah, that's how you should go. You should follow this. You should follow lay down rules and processes because um, it's better that way. But it's not always ideal for the business. So just make sure that whatever you're building at each project, each product, however you're building, just make sure that is in tune. Your stakeholders are button, your stakeholders are happy, and your users in turn will be happy. So SDLC helps achieve this goals by identifying inefficiencies and higher costs and fixing them to run smoothly. So how does it work? The standard design simply outlines the tasks required to put together a software application. This helps to reduce waste and increase the efficiency of the development process. Monitoring also ensures the project stays on track and continues to be a feasible investment for the company. So again, monitoring monitoring has to be done with the team. And the product manager, yeah, your stakeholder or people outside your team should be involved in, should be abreast of what you're building, should be giving regular updates, daily and all of that, daily, weekly, monthly, however the organization they should know at what stage your the development process is into. But what you should not allow is, and this is one of the things that might be different when you start working, but I don't allow it, is direct monitoring. Someone that your CEO being in your daily stand-up is worrisome, or being in every meeting and all of that stuff. I thought maybe it's a startup um that has 5 employees or 10. Okay, a lot of us should come now. So what's the difference? But then again, it's monitoring should come from the team itself. It should be a self-organizing, self-sustaining, self-development team. That should be no outside monitoring. The CTO can come once in a while, but his presence is not needed every time. So if you see it happening, your CEO, your CTO, or your CMO coming, or even your CPU, Chief Product Officer, coming to your team meetings regularly, call it to the attention one time and say, sir, ma, um, we're not very comfortable with you attending our meetings regularly. While we welcome your presence and we appreciate you coming to join us, it should not be a constant thing that should happen. My team feels comfortable with us being a team and working things out on our own. Anything you need as a product manager, you will get it from me. It should be brought to your attention. But other than that, please don't be coming to us stand up every day. It's not very, very helpful for the overall improvement of the overall um just the overall improvement of your team, whatever. So again, so yeah, that's it. So again, but and again, that's why this SDLC is very, very important. It helps you make sure that things are being accounted for and things are not being done anyhow, and you're able to track progress and all of that. So again, we have planning. In the planning phase, project leaders evaluate the terms of the project. This includes calculating labor material costs, creating a timetable with target goals, and creating project teams and leadership structure. So, as a project manager, you're mostly going to be the one in charge with your your stakeholders, the senior stakeholders, and your users, customers, and this is a high level meeting. Even your team should be involved. So you plan everything, calculate, don't do some this sort of stuff. Again, planning does not happen once or twice. It can happen at a period of time. Then you define requirements. So it is also considered part of planning. So it is determine what the application is supposed to do and its requirements. So you get the requirements, think that the features to build and how and where it's going to be built. Then you design. The design phase models the way software application works. So um some aspects of the design phase includes architecture, user interface, platform, programming, communication, security. So you design and uh, you just design and make sure that in all these places that what you're designing for is facing the customer, like it is what the customer wants, like, and also for your business too. It is going to help your business objective as a long run. Then develop. So this is the actual um, building of the software. So this is where you write your codes, write your everything, and build software to make sure that it's working. And um, since things are like development. Sorry, I like I mentioned earlier, by six you should be closed. We should be done with this class. I don't know if I'll be able to take questions because I have a very important meeting with my CEO and other stakeholders. So we can have hopefully by tomorrow. I'll clear my calendar. So after the class tomorrow, um I'm basically done. Yeah, this is all the things we have for this week. That reminds me. So tomorrow will be for Q&A, question and answer segment. So anything you don't understand today, please bring it tomorrow. Make sure you note it, and we'll discuss and talk about other stuff tomorrow. Um, I'm just watching my clock, and it's almost 6 p.m. So I'll be winding up any moment from now. So yeah, you develop, and this is the actual process of building a software a product, then you test. So after building, you test. After building a feature, you test. After building a product, you test. After testing, make sure that it meets the minimum requirement. Remember when we talked about writing user stories and acceptance criteria, yeah, testing comes and make sure that what you build meets that standard, and then you deploy. And once you deploy, your product is now live. And then here is now the back end, operations and maintenance. Whatever is not working right, you iterate, you maintain it, and you build it. So that's basically what um, the software development life cycle entails. So with that, I think we've come to the end of the lecture for today. Again, apologies. Is this not the ideal setting would have hoped for? My screen is supposed to be on. Let me share my screen, and we should have extensive time. Sorry, to learn about the development methodology. But again, thankfully, I finished everything I have to teach for today. For this week, and then tomorrow, please come with your questions. Come with everything that's confusing, and we'll discuss it tomorrow. So again, thank you guys so much, and I hope this class you've learned one or two from this class, and um, you just be a better product manager after here, and tomorrow we'll go into more details. So thank you, Ngozi. Thank you guys again, and have a great evening.
Bye. Good luck with your meeting.
Thank you so much,
Thank you, sir.
Sandra.
Thank
Thank
you.
you.
Thank you.
Thank you guys. Thank you. I appreciate it. All right. Take care, guys. Bye.
Marv.
Bye.